right, so we want to learn how to fill out a complete panic model. This is something that will help guide you through the steps that you need to make sure you include everything you need to include for your confidence interval. All right, so the first thing that we need to do is what's called the P in the panic model stands for parameter. That is, we want to define exactly what it is that we are hoping to generalize to, or what are we making an inference about the whole population. A couple of things. We need to make sure that we are using a mu for the mean or a p for the population. We want to make sure we're using present or future tense. So we do not need to infer about what has happened in the past. That's already past. We could get those facts and tell you what happened. Inference is going to be happening about the now or the future. So make sure your verbs are not about past tense. Also, you need to make sure you are clear when you talk about a proportion about what the denominator and the numerator are. And so as we go through one of those, then I'll make sure that I demonstrate that and model it. All right. And then the A in the panic model is our assumptions to get to that approximately normal model applies. So that's our random, our independent, and our large enough. And this was just proportions, so I just put the proportion large enough here for n times p, or n times 1 minus p are greater than or equal to 10. Remember that if it's a mean problem, then it's n is greater than or equal to 30, okay? But for proportions, which we're doing in this lesson, then it's that 10. Now, for naming our interval. So this is the only name you would know so far, okay? It is called a one proportion z interval. So one proportion, because we're just dealing with one proportion of data, will eventually have two. And it's a z interval because, well, it's on the perfect normal model. We eventually will use t curves and do t intervals and t tests, and we'll talk about what that t is instead of the z when that time comes. But it's a one proportion z interval, so that's all you put right there for now. Then the I is where you show your work for your interval. Make sure you define your parameters. So your p hat, put what that is, your critical value, inverse norm, one tail, and then your standard deviation. Show your work of getting your statistic and then put the interval there. Your conclusion is that conclusion about saying, I am blank percent confident that the true proportion of blankety blank 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 is between this percent and that percent. Okay? And that's your confidence interval conclusion. There's something else called a confidence level conclusion, but that's a separate lesson that we will do, and we'll come back to that at a later time, so you don't need to worry about that. All right, so let's do this one for this presidential Pete problem. So here we have our panic model for presidential Pete interval that we want to make, and we are making a 95% interval, so here we go. So the parameter that we are doing, what is it that we are trying to infer? We want to infer. So P equals. This P is here not because it's the P of the panic model. This P is because that's the proportion value that I am making an inference about. So it's the proportion of voters who would vote, who are going to, or who anticipate voting for presidential Pete. Okay? And it's not who voted. Voted, it's not past tense. All right. Now then our assumptions and our conditions, that's our getting real. So our random, it was stated that we had 1,020 randomly selected voters. We were independent when n is less than 10% of all such voters. Large enough is tricky because it all depends, mean or proportion. Now, on these problems, they tell you the successes. So you actually don't have to demonstrate n times p and n times 1 minus p because you have the values there. I mean, you know that in the sample, 484 is what you got. That's all we have. And so then there's the failures, the ones who did not. And so the approximately normal model applies. Remember, the best it can be is if you use true p. Okay, but we don't have that, so we have to go with our p hat, our sample results. All right, so now the name of that confidence interval is the same for this unit, 1 proportion z interval. And now we're going to make it. So here is that formula for making our interval. Our statistic, that's our p hat, plus or minus our critical value, times our standard error of the statistic. So I've come over here to the side, and I've put those values here. So let's see. So over there, we know that our p hat was 428 over, or 484 over 1020. Okay, so 484 over 1020, and that's 0.47. So that's our p hat. We did our inverse norm of 0.025 for 95% confidence. That's one tail. And then our standard error was that p hat times 1 minus p hat over n, 0.016. I'm rounding to two significant figures. So there's my statistic, my 0.47, plus or minus that critical value times that standard error of the statistic. And then I'm going to do my adding it or subtracting it. So there's my adding it, and there's the subtracting it, so that I get my two answers, so that I get my interval 0.439 to 0.501. All right, so that's making the interval. Now we just do the conclusion. So I am 95% confident that the true proportion of voters who would vote for Presidential Pete is between 43.9% and 50.1%. Now, I think this question, this prompt may have asked another question. Yeah, do these results provide evidence that Presidential Pete will win the election? Explain. And that answer is absolutely no. You cannot say it's more likely because that he'll lose, because more of this interval is below 50%. No, you cannot address more or less of it being below, because your p hat is just because of sampling variability. Someone else could have just as easily gotten the mirror image to your interval. So you cannot say more likely one way or the other. Yours is just sampling variability. So all you're looking for is if 50% is in there or not. And we have that there. These results do not provide statistical evidence that Presidential Pete will win the election. He might, because he could get 50.1% of the votes. But he could also lose, because there's part of my interval below. The interval is above and below 50%. Therefore, we cannot tell if he will get the majority of votes. Again, do not be tempted to say it is more likely that he will lose. That is a no-no that you cannot conclude from this interval. All right, that is how you complete a panic model. Now you're going to practice some of those on your own. And from now on, if you're asked on a free response question to complete an interval, this is actually what you're expected to do, a complete full write-up, unless it says you do not have to. But otherwise, it's assumed that you have to do this. So there you go, how to do a complete interval write-up.